Thanks to Emily, my name is Nima, and I'm going to talk about this very interesting research that we are doing here at KTH about social networks. And social networks, it's something, I'm sure all of you have several accounts in different networks: Facebook, Twitter, Google+, LinkedIn, Instagram, and et cetera, et cetera. But I guess it's very interesting for you to know what sort of software is running behind the scene in these systems. And then I'm going to focus on a very specific type of these software, which we call recommender systems. So to begin with, I will just guide you through the outline of the talk. I will introduce you to these type of systems. What is a recommendation system? What sort of examples do you have already, and you have probably definitely worked with them. So hopefully you will get the idea of how the systems work and what sort of stuff is interesting for us researchers that we look into these systems and what do we analyze. And then I will talk about the benefits of building these systems in social networks and using the social data. So what sort of benefits using social data gives us. And then I will show you some parts of our research. In specific, we have results of using social trust for improving the recommendations you can get, and how to improve the user privacy while using these systems. And finally, I will focus on a bit more specific types of recommenders that you work with in Twitter and review sites like TripAdvisor. And I will say how we mine the people's opinions from these sites. Okay, to begin with, the whole story behind this sort of systems begin with so much data. Facebook processes, according to some unofficial news websites, 4.7 billion status updates. That's a lot. That's a lot for computers to handle. Twitter processes over 200 million tweets per day. That's also a lot. So for the systems to be able to find interesting stuff for you, they have to come up with some certain types of algorithms, computer software that can go through these updates, tweets, photos, etc., and they come up with those that they think they suit you best. This is what we call a recommendation, and this effect that you get is called personalization. To be more specific, you make a profile everywhere these days. You have a profile on Facebook, you have a profile on Twitter, you have a profile on Instagram, and what you do is save there, and the algorithms, the recommendation algorithms, are going to use that to just pick up those news, those updates, those tweets that they think suits you. They are personalized for you. This is what we call recommendations. We have three specific types of recommendation systems. So one of them is called content-based. So items similar to this, similar to that. So you search for a book on Amazon, you get the books that also are similar to the ones that you have searched for. These are content-based. So just the content that are similar to what you have seen or bought. The other one is called collaborative filtering, which is user-based. This gets close a bit to more social ones. So the system will look for users that have given the same behavior as you. They have rated the same movies. They have watched the same photos. And then they will try to just come up with those that the other users have looked. And the more modern cases is the hybrid, that they mix both the stuff that is based on the stuff that you have watched or rated or have searched for, and the stuff that people similar to you have gone through. So finally, the good part. You can see some examples of recommendation systems that I'm sure you have been working with extensively. So let's begin with the Google case. When you type something in the Google box, even to start with, you get your queries expanded. They get completed. And as you can see, I have searched for mining social networks, and then you see some suggested expansions of this query. And you can see there is one that says, and security informatics. There is one that said, for personalized email something. So security is something that I've searched for previously on Google. Personalization is something that I've searched previously on Google. And Google knows that because it has your profile. So it goes through your previous searches, and then this suggestion of the queries that you're going to search for is tailored based on that. This is a content-based recommendation system. Another very interesting example is the one that Amazon has. So I've searched for a book called Recommendation System. And at the bottom of the page, you see that customers who have bought this book, they also have bought these books. So, and these books are similar to the ones that I've searched for. Again, another example for a content-based recommendation system. You have the TripAdvisor. So I have searched for Novotel Hotel in Paris, and then you see that it has suggested me to look into all other Novotel hotels in Paris as well. So exactly the same thing I've searched for, it's suggesting me, it's recommending me. And the Netflix. So the Netflix is interesting because you have the ratings. So you give ratings to the movies that you like or hated, and then the system processes this, and then it comes up with the suggestion of the movies for you to watch based on these ratings that you have given. This is an example of the user-based. And the ideal case that is the subject of our research is the example from Facebook. So these are the pages that are suggested me to like. And then you can see that, for instance, this celebrities on Facebook, one of my friends plus 12 more, they have liked it too. So the reason it's suggested to me is because my friends have liked it. And there is other ones like IKEA's Sverige. So as you can see, one of my friends has liked it, so it's suggested to me. But these are the ones that my network have liked. What about the other ones, like this Mean Streets or the one above that? I don't get it. Where did they come from? Why they are suggested to me? So this is a case that it might be mix of both user and the contents that I've already, or my network have already viewed. So some examples to just get you started that what these systems are. What's interesting for us in research? So first of all, the example from the Facebook. Explain the recommendations for me. Where does this page that you have recommended me comes from? I don't get it. If it's not written that is liked by my friends, okay, then why you're suggesting me that? So we are trying to make these algorithms better to show us reason, to show us the trust in the system that these are suggested to me because of this, because of that, more transparency for the system. Recommendation systems, they take a lot of data. The more your personal data goes in, the better they should perform, and they will get as much as possible, and they're still hungry. And you don't want to give too much personal data. I mean, how much of your personal life you're devoting to different websites? You just want to give enough as long as the system gives you good performance and gives you good results. So can we find a middle ground for the privacy so you give enough data and you get good performance from the system? This is also something that we research. Diversity and novelty. These systems, they suggest you stuff similar to this, and they tend to keep suggesting that. Give me new stuff. I mean, why you keep showing me the same people? Why you keep showing me the same pages? I like to experience new stuff. I like to meet new people. So these are the problems that we deal with. But then social networks, they, especially the online ones that you work with, they became popular, and the more data they showed, the more easier it became for the researchers to tackle these problems. So as you can see, we have two types of relationships. We have the explicit ones, so the ones that you show on the networks. You're friend with these people, with that people on Facebook. You follow these guys and that guys on Twitter, for instance. And also, there is implicit. So there are relationships that are not visible, but we can compute it. So if you and some other people have liked the same movies, I can say that there might be a relationship between you and these guys with respect to your interest toward these movies. So we can analyze all of these relationships and we can take advantage of them. But what sort of advantage we can get from using these relationships in social networks? So first of all, you have these relationships documented. So if you have shown your trust towards somebody on the network, well, I know that you trust this guy who writes reviews about hotels, and you keep reading his reviews, you keep giving good ratings to his reviews on TripAdvisor, on Yelp, on Amazon, for instance. So I can use that. So you follow this influential guy on Twitter, on Facebook, celebrity politician, for instance. So I can use that because I know that you have shown this interest toward this, his or her. And at the same time, one of the good things about social networks is that fighting spammers and fraudulent accounts has become easier because it's obvious you don't add someone who is a spammer to your network. You don't add someone who is fraudulent and shares falsified information with you. You add people that you know. You don't add a software that creates spam for you. And we also have this cold start, like the car that has a problem to start. These systems tend to not function when they don't have enough data. So, but on the network, you always have people that you can, by their consensus, by their opinion, you can use their data, and you can always make these systems work. So these are the benefits that social networks can give for making suggestions, for recommending stuff to people. So I would like to now show you some of our research. So hopefully you have got a rough idea of what we are exactly doing. So the first part of the research that I will show you is the part that we are modeling trust between people. So based on the interest that the people share for the movies, for the stuff they share online, as I said, we can compute some sort of metric, some measure of how much these people might trust each other. And then we can use that to improve the recommendations we give you. So we can build recommendation systems can give, in fact, better information than the ones that you are working with online. And also I will show you how we build these networks, in fact. But some nice picture, first of all. This is how we visualize the networks. This is a trust network of a review website called Chao. And as you can see, there are these lines between the dots. So the dots are actually people. And the color differentiation hopefully makes you see this a bit easier. And then the lines between them are actually their trust relationships. So we visualize this to see like where the cluttered places that people are trusting someone more than the others and where the ones that are isolated. So we can analyze this visually as well. But how we build these trust networks if we don't have them already? So let's say that we have your ratings from the Netflix. We gather all of the users' ratings and then we try to come up with a network like those guys sitting over there based on our trust metric, and we compute how the ratings given to the similar movies are. So if you have rated the same similar movies, the same as another guy, you probably would be interested in following this guy. You probably won't be interested to get recommendation from this guy because you share the same taste. And then we keep calculating that and we come up with this nice visualization of this network here. So then we get this trust network. And then on this network, we begin to calculate what sort of ratings people might assign to the movies. And we already have the people's already given ratings, so we can compare. And this gives us how accurate the recommendations we give are. We can also, as I said, look into the structure of these networks and see how people trust each other. So the one on the left is generated without using a trust metric. So the way it is, whatever people have liked and they are following each other, and this is based on a movie data set, almost like Netflix. But if we do that with our trust metric, we get the one on the right side. Now, can you see the difference between these two? So the one on the right, you have more density of the nodes in between the graph. So you see there are more dots in the middle of the graph, which basically shows that our algorithm has been able to find trustworthy users and share them between the other guys around. So we can identify these people and then we can share it with the rest of the network. Hey, these guys are expert in these type of movies, in this type of music. So maybe you like to get recommendations from them. So this is a visual example. We also do this numerically to see how accurate our recommendations are generated. So these two graphs, for instance, show us the accuracy in terms of error. So for instance, the larger the size of the trust network, we go on the right side, the lower the error is, so the algorithm is more accurate. And on the right side, we can see that the larger the size of the network, the more users we can give recommendations to. Because as I said, size of the data is always a problem on the net. So we can statistically, numerically show how good our algorithms work, how good we can recommend stuff to you. At the same time, we can also compare to the other approaches. So for instance, in this image, you can see that we have compared our approach with two other approaches. So on the left side, you see we are referring to O'Donovan's approach, and we are showing that in terms of accuracy and also the coverage, we are doing better job than him. So we can show the value of what we do and compare it to existing ones, online or offline or in research. So this was a snapshot into the part that we do research on trust and how we can improve the recommendations based on trust. I mentioned privacy. So when it comes to privacy, it's a matter of control. You just want to have a control on how much data you're giving to the system, and at the same time, you expect the system to give you still good suggestions and recommendations. Can we come up with this level? Can we find a middle ground that you can control your personal data going on the net and still having the systems behaving the way they should? For these, we have proposed for software architectures that can change recommendation algorithms. So in this image, the gray boxes are the formulas and algorithms that we have injected inside the system, inside the recommendation system. And in these parts, we actually add more privacy to the computation. We add more protection to the data during the computation and also make sure that the system's functionality remains intact. Because as I said, that if we take away too much data from the system cannot work properly. And again, like the previous examples, we are capable of also comparing and showing that we can do good job compared to the other approaches and still maintain the user privacy. So for instance, in this approach, the red line is another approach, the yellow line is another approach, and the blue one is ours. And in most of the diagrams, we are doing better job than the compared approaches. So we take trust into account. We have analyzed the privacy. And now it comes more recent types of data on Twitter, on review websites. So the text has become something that people are uploading to the net. Your Facebook status updates are text. The reviews that you write about the hotels you have stayed are text. So we need more recent approaches that can deal with this type of data. In specific, we would like to see how we can diversify the opinions of the people so we won't get all the times boring same stuff. And at the same time, we would like to also see if we can recommend tweets, for instance, if we can recommend users, at least better than the way the Twitter is doing. So I've put some review on the left side. It's about an airline company. Somebody wrote online. So it turns out that he was happy. So he has assigned good ratings, 4 stars out of 5, and he has written some nice text. Of course, you find lots of also negative opinions. This is a positive one. So that is a topic model. This is the model that at the moment, for instance, Twitter uses to understand your interest and suggest you people to follow. And we are using this to come up with a topical representation of people's opinion. So you have 900 reviews, and then we go through this, we come up with a topic map. So just show you these topics that the opinions of the people about this airline has been like this, like that. And based on that, we can show that if these opinions have been positive or negative. So for instance, for 4 products we have looked into, we have been able to show that if people have been happy with the products that they have been consuming, they have given also good ratings. And if they have been really saying bad stuff about these products, they have also been giving very low ratings as well. So as you can see, the green one, blue ones, they are positive ones, and then it goes towards the lower colors like orange and yellow, it becomes a negative opinion. And also, again, we can also statistically analyze if we are doing a good job for diversifying opinions and the ratings people give on a review website, in this case, as I showed you, for instance. But how about Twitter? Can we do the same on Twitter? So I'm showing you two cloud representation of these topics that we have extracted from two trends from 2011. So for instance, we had the Eurozone economic crisis, and there were lots of tweets on about this. And you can see that these big topics, they have been mentioned a lot. That's why they're bigger than the small ones back there. So economics, bailout, EURUSD. So the EURUSD is euro to US dollar conversion. There are lots of tweets mentioning the conversion of the rates because the economy was getting affected. So even by looking at that cloud representation, we can understand a lot of things about what these tweets have been mentioning. The lower one is about WikiLeaks, and as you can see, the biggest topic that has been more frequent is Julian and Assange. And then if you go a bit lower, you will see that there is a leak somewhere, there is a terrorist somewhere, all of a sudden there is Mubarak. So as you can see, we can say that people who have been talking about, for instance, WikiLeaks, they also have been following other events as well, because these are the tweets that belongs to them. So even by extracting these topic maps, these topic models, we can understand a lot of things. And we can also recommend users based on these topic models. So for instance, you are looking at different approaches we have used to recommend people on Twitter based on the topic maps that come out of their tweets. And then we can see how accurate we are doing with respect to the different approaches that we are using. So this was basically a digest of my talk. And I'm concluding here, and I'm telling you, if you're interested in this field of research that we are doing, analyzing social data, working with recommendation systems, these trends are going to go under data science and big data. So these are two trending subjects that industry and academia, they are both working on. There are a lot of jobs created based on these, and there are a lot of companies looking for people that have talents that can analyze data from social networks, that can build recommendation algorithms that can suggest these data, for instance. So if you like to follow this. And then also KTH and other European institutions are proposing curriculum and programs that can teach data science and also big data skills. So hopefully this will come out very soon. Thank you very much.
Are there any quick questions?
Hey, are you familiar with the Facebook poke system?
Facebook?
Poke system, you know,
Poke
pokes
system.
and etc.
Sure, yeah, of course.
Well, if you look upon it, you could see it as some kind of flirting tool with other Facebook users, right?
Okay.
Yeah. So how does these poke suggestions work? Is it the same with people having a lot of acquaintances and liking the same kind of pictures and etc.?
Well,
yeah.
Okay. So the poke system, as long as, okay, so if you have been poking people, I guess it's more probable that the system will also suggest you more people to poke, or then the other way around. But definitely, I'm not so sure how exactly the algorithm behind it works, but then it's going to fall under one of these categories that I've showed you. Yeah.